Hello everyone, welcome once again to my channel. Now in this section we are just going to talk about central limit. What is the whole idea behind the central limit theory. So I'm going to explain that based on two distributions. We have the normal distribution and also the sample distribution. So with the normal distribution, so let's take this one to be the normal distribution. And then we have the sample distribution here. So sample distribution. Yeah. Now we have the normal distribution, also the sample distribution. Now with the normal distribution, there's x here approximate the normal distribution, which is given by the mu and then also the standard deviation. So when we sketch the normal distribution graph, something like this, we have the x here and then also the mu here. Good. Now that is the normal distribution graph. Now in the case of sample distribution, we use the sample mean. So over here, this is called the sample mean. So let's separate it. So we have the sample mean here approximating the n here, which is equal to the mu, and then this time it is just the standard deviation here divided by the square root of n. So that is the difference between them. And then when we sketch this, we have this distribution to be. So over here we have the sample mean rather, and then also we have the mu here. But in this case, the mu is with respect to the sample mu. So the sample mu written as that, right? So that is the difference between them. Now another thing is that apart from this, we also have the z distribution, or the z-score in this case. Now for the z-score for the normal distribution, so under normal distribution, the z-score is given by so under normal distribution, the z-score is given by the x, we are using the s in this case, minus the mu divided by the standard deviation. And then also under the sample distribution, the z-score is written as the sample mean minus the population mean divided by the standard deviation over the number of samples in this case. So now using this formula depends on the kind of question you are being given, whether it is a normal distribution or you are being given a sample distribution. So if it's a normal distribution and then you are finding for the z-score, you have to use this. If it's a sample distribution, you use this. And then most of the time we use z when n is greater than 30. So when the number of samples which we are being given is greater than 30, we use z. But then in the case where n is less than 30, less or equal to 30, we use what we call the t distribution or the t-score. So the t distribution is given by some alpha here and some degrees of freedom n minus 1 here is equal to the sample mean minus the mu divided by, but then in this case we have the standard deviation written as x divided by n. So we use this formula when n is less or equal to 30, and then when n is greater than 30, then we use the z-score formula. Okay, so that is basically that. So we have one formula here, we have two, and then we have that is for the normal distribution. And then for the sample distribution, when we are to find the mean, the sample mean, then we use this. And then for the z, that, so let's call this one 3, and then let's call this one 4, and then let's call this one the t here, let's call that one 5. So we have these 5 formulas, and this is what we are basically going to use in solving the central limit theorem. Any question on a central limit, these are the 5 formulas. It's just that you have to know whether the question is on normal distribution or it is a sample distribution question. So if it's a normal distribution question and then you have to find the mean, then which means that you have to basically use this just by locating the mu here and that of the standard deviation. And then if you have to find a z, in this case you have to use this formula. But then if it is a sample distribution question, then you have to consider using these formulas here depending on the conditions which are given. If n is greater than 30, we use this. When n is less than 30, we use that also. And in this case too, we also use this formula here when the standard deviation, which is this one, is unknown, when it is unknown. But then in this case, our standard deviation is written as x, not as mu. So take note of the difference. So these are the formulas that we are going to use in solving the questions. So I'll see you in the next video for us to solve more questions under central limit. So